So we studied the measure of central tendency in the last lecture. Today we are going to pick one of its attributes, which is arithmetic mean, or is it also known as average. So what is arithmetic mean? It's a way to find the central value of any set of numbers or a data, and it is calculated by adding all the numbers in the set together and then dividing it by the total count of numbers. So it represents a balanced point within that data, and thus we can say that it's the quotient obtained by dividing the sum of all observations by their number. So it is basically represented by capital X, which is equal to capital X bar, which is equal to sum of all observations upon number of observation. Here the sum of observations is represented as sigma x, small x, upon capital N. So the basic formula is this only. Then comes the types of arithmetic mean. So there are basically two divisions. The first is simple, ordinary, or unweighted mean, which we just did, where it is capital X bar, which is equal to sigma x upon capital N. The another category is weighted average mean. Now what is the difference? It is represented by it's represented by capital X W, which is in subscript, will be equal to sigma wx upon sigma w. Now it is used in the situation where x1, x2, x3 till xw are the values of any variable x in a series, and certain weight is being assigned to those values, which can be represented as w1, w2, w3 and further till wk, or it can also be taken as ww, is just to represent the series. There is an entire series. So when there are certain weight attached or assigned to the values of variable in a series, then weighted average mean is used, and the formula is given here, and every place that sigma represents summation or the total. Now in the context of calculating the arithmetic mean or average, data series on which it is applied are generally categorized into three types: individual series, discrete series and continuous series. We'll see how this happens and what kind of application is there and how it is calculated. Now there are three major methods to calculate this arithmetic mean. The very first is direct method, then comes the shortcut method, and the third one is step deviation method. So I have started here with the calculation of arithmetic mean in individual series using the direct method. So there are two major steps. First of all, we add all the values of the variable capital X or X, and so as to obtain sigma x, that is total of x, and then we divide this total observation sigma x by the total number of observations that we saw in the formula earlier. So it's like x1 plus x2 plus x3 till the series goes on to reach the point of xn upon capital X, that is sigma x upon n. So here I have taken it for the application part. I am taking a question here where monthly income of 5 people is given, and we have to find out the arithmetic mean. So I have made this table putting the serial number in first column 1, 2, 3, 4 and 5, since there are 5 people, and I have put in their monthly income in rupees in the second column. So here capital N becomes 5 because there are 5 number of people, and the monthly income, the total is being taken. So I have added all these values 1132, 1140 and further on, so as to reach the total of their monthly income, so as to reach capital X. We'll simply put the values in the formula where x bar or mean will be equal to sigma x upon capital N. Sigma x here is 5700 upon n. We already know that it's 5, so it's 5700 upon 5. So we got that to rupees 140. So this is the arithmetic mean here when it is the individual series and we have applied the direct method. Now the process of computing mean by shortcut method in case of individual series, it has the following formula where x bar is again mean is equals to small a plus sigma dx upon capital N, where this a small a is a assumed mean, which is often known as arbitrary or origin also. Then what we do, we take the deviation of each item from the assumed mean small a and denote this deviation by dx, that is dx is equals to x minus a. Then thirdly, we obtain the sum of these deviations to find sigma dx and then use the formula x bar is equals to small a plus sigma dx upon capital N, where n is the number of items again for computing the arithmetic mean. Let's see how we have done in the question. So here the marks obtained by 10 students in an examination are given below and we need to calculate the mean by shortcut method. As we can see that the roll numbers are given and the associated marks are also given. So we'll draw a table here taking the marks obtained, which will be our x in column number 1. So we'll put it accordingly. We'll put the marks obtained in the same order as given in the question, and we need to have the deviation, which is dx. So we are taking an assumed mean with the value of 50. Now what we'll do, we'll take the deviation from the marks from the assumed mean, which is x minus 50, because 50 is the assumed mean. So we'll calculate our second column. Here we'll put the value of we'll take the difference between the value of x and the assumed mean. So the first entry becomes minus 7 because it is 43 minus 50, which is the first entry. Then accordingly further, like 48 minus 50, 65 minus 50. So the corresponding values are coming, as you can see in the second column. Now we'll take the total of this second column so as to get the sigma dx that we need to put in the formula. The total comes to be 69 minus 43, which is 26. Now we'll simply put the values in the formula. Here we know that assumed mean small a is 50, then sigma dx is 26 and capital N is 10 because there are 10 students. So the answer comes out to be 52.6 marks. This is the mean value here. Then comes the step deviation method. So in step deviation method, we change origin and scale both. That is, we compute ds small s which is equal to x minus a upon I, where a is assumed mean, I is the common factor in the values of the series x1, x2 till xn. So here the arithmetic mean is given by the formula x bar is equals to a, which is the assumed mean, plus sigma ds upon capital N multiplied by this common factor I. Now the next I have taken is the calculation of arithmetic mean in discrete series or discrete frequency distribution. So here the formula is sigma fx upon n, where again that capital X bar is the arithmetic mean, sigma fx is the sum of the products of the values of x, that variable जिसकी series है, and the corresponding frequencies, and sigma n will be the total of that frequency. Let's see how. So here I have taken an example of this question where we need to calculate the mean from the series where the size and frequency both are given. So we'll draw a table. We'll start the solution. We'll draw a table. We'll take size of the items as x, small x, which will be the first column. Then we'll put the frequency small f in the second column, and we'll put the values accordingly, like 6, 7, 8, 9, 10, 11, 12 will go in the first column as x because they comes under the size of the item. Frequency will be written, associated frequency will be written next to them. Then we'll need the third column, which is fx, where the product of frequency and the size of item will be calculated. So we'll multiply both the columns 1 and 2, like 6 into 5 equals to 30, and further on. So here frequency will take the total of frequency, that becomes the capital X. The total value is 50. that is the total of column number 2. Then we'll take the total of column number 3, which is sigma fx, that comes out to be 440. We'll simply put the values in the formula, which is sigma fx upon n. So we'll put it as 440 upon 50, that comes out to be 8.8, which is the mean here, or the answer. Now I've tried to take the third category also, which is the calculation of arithmetic mean in grouped series using the direct method. The formula here is sigma fm upon sigma f, or we can say sigma fm upon capital N, or sigma fx upon n, where this m is the midpoint of each class, because there will be class intervals given. N is the total of frequency, which is sigma f, and f is the class frequency. Let's see. Now here there is a question given that we need to calculate arithmetic mean for the following frequency distribution. You can see that there are 2 columns. In column number 1, income is given in class and number of person falling in that class interval. So the class interval are being taken as 0 to 1, 1 to 2, 2 to 3, 3 to 5, 5 to 10, and further on till 100 to 1000, where 2 people are falling in the last entry of column number 2. So what we'll do, we'll again draw the table where income frequency will be taken in the first 2 columns, and for the mid value we'll draw a third column where the mid value will be calculated from column number 1. For example, in the first entry it's 0.5, where the mid value has been calculated from column number 1, which is the income scale interval is 0 plus 1 upon 2. The average has been taken, so it's 1 upon 2, which is 0.5. Further on, in the similar manner, we have taken the average or the mid value from column number 1. For example, the last entry is 100 plus 1000 upon 2. So we have got the value as 550, which is the last entry in the mid value or the third column. Now we need fx, where f is frequency and x is the mid value. Since there is class interval, we needed a particular value for the multiplication. That's why we have taken the fixed mid value from the class interval. Here we have taken the multiplication, the product, and have taken out the sum, which comes out to be 3254.5. Now we'll simply put the values in the formula, which is where the mean is calculated by sigma fx upon sigma f. So sigma fx, which is the total of the last column, or we can say the fourth column, which is 3254.5 upon sigma x, which is the total of the second column, total of the frequency, which came out to be 404. We have taken the division, the value is 8.06. So this is the arithmetic for the following frequency distribution. This is how it is calculated when it comes to be the case of grouped series where the class intervals are given. Hope it could cover a bit. Thanks.